Hello students, very good morning. Welcome to Narayana Live Classes. Today for class 10 students, we are going to discuss assignment number 30 on similar triangles. Let us start with the first question. PQR is a right angle at P and M is a point on QR such that PM is perpendicular to QR, then PM square is equal to. Okay? So let us take the solution. What is it saying? PQR is a right angle at P. Here we have the right angle. This is Q and this is R. We are drawing a perpendicular on QR so that it is meeting QR at M. So PM is perpendicular to QR, that is given. Then what is PM square? What is PM square? For that, we have different ways to solve this question. One of the ways, let us take, if you take this triangle, what is a triangle? In triangle PQM. In triangle PQM, what you can take in triangle PQM? It is also right triangle because here it is 90 degrees means this is also 90 degrees. So as it is a right triangle, QP is the hypotenuse there. So QP square is equal to QM square plus PM square. So we can say QP square is equal to PM square plus QM square. Similarly, second triangle, if you take in triangle PMR, here also we can say PR is the hypotenuse. So PR square is equal to PM square plus MR square. Let us add up these two. So we have PR square plus QP square, that is going to be 2PM square plus QM square plus MR square. That is what we have. But PR square plus QP square plus PR square is nothing but QR square because here we have the right angle. Therefore, here in this place we can write QR square. So QR square is equal to, you have 2PM square plus QM square plus MR square. Fine. Now, but QR is this total length. QR can be written as QM plus MR. We can write QR as QM plus MR. So it is nothing but QM plus MR whole square. So this result becomes QM square plus MR square plus 2QM into MR. That is going to be, this result is 2PM square plus QM square plus MR square. Observe here, these two terms and these two terms cancel, and both the sides we can cancel. So what is left out now? QM into MR is equal to PM square. So PM square value is equal to QM into MR. PM square is QM into MR is nothing but first option for us. That is the right answer. So entirely we are using properties of right triangle here. Pythagoras theorem we are using in every case. Right? Let us see the next question. ABC is an isosceles triangle, right angle at C. Then AB square is equal to. We are given that ABC is a right angle at C. So let us take this as A and this as B. Now, isosceles, it is even isosceles triangle. So these two lengths will be same. Anyway, none of them can be equated to hypotenuse because hypotenuse length must be more than that of these two sides. So only the possibility is that these two are equal sides. If these two are equal sides, AB square he is asking. So let us use Pythagoras theorem in triangle ABC. AB square is equal to AC square plus BC square. Okay, but if you look at that, AC and BC both are same. As AC and BC both are same, the same I can write as AC square plus AC square. BC and AC can replace, that is otherwise 2 times of AC square. So AB square value is 2AC square. 2AC square is the right answer. Of course, here if we have an option as 2BC square, that is also a right answer. But we have only BC square, so only third option we are considering. Right? Let us take the next question. Two poles of height 6 meters and 11 meters stand on a plane ground. Okay. If the distance between their feet, this is given 12 meters. Let us draw the horizontal here. Let us join these two. Okay. So this is a pole. Suppose this is some AB. This is some CD. Now we have a point E here. Okay. So these two are the poles. First pole height is 6 meters. Second pole height, this total height is 11 meters. As this is a right rectangle, if this is 6 meters, this is also 6 meters. So this length is 6 meters, then obviously this length will become 5 meters because 5 plus 6 results in 11 meters. So here it is 12 meters, as these two are opposite side, they are also equal in length in rectangle, so that is also 12 meters. So we have AE length as 12 meters, DE length as 5 meters. Now what are you asking? Then the distance between their tops. Distance between the tops is nothing but AD. AD is the distance. So here we have a right triangle because all are poles and this is a horizontal we are drawing. So here this is perpendicular as these two are parallel. Okay, as these two are parallel lines, this is also perpendicular. So simply we can say in triangle ADE, AD square is equal to AE square plus DE square. That is 12 square 144 plus DE square is 25. That is 169. Therefore, AD will be root 169, that is 13 meters. The distance between the tops is nothing but AD here, and that AD becomes 13 meters. 13 meters is nothing but third option. Here, of course, we have to take meters. Okay, because it is not centimeters, it is also meters. Meters is right thing to take because the data is given in meters, even answer must be in meters. Now, let us see the next question. 3 times the square of any side of an equilateral triangle is equal to dash times the square of the altitude. Let us suppose this is an equilateral triangle. All 3 sides are equal in length. Let us take the altitude on the base. We know that in an equilateral triangle, the altitude divides the base into 2 equal halves. So, if at all this length is some A, this is A by 2. This is also A by 2 because these two lengths are same. And one more thing, it is right angle here. So here this is D that we take. Okay. Now in triangle ABD, what you can take? AB square is equal to AD square plus BD square using Pythagoras theorem concept. That is otherwise AD square. What is AD square unknown? That's what is BD square? That is A square by 4. So AB square is A square because we are taking the length of AB as A. That implies AD square is how much now? A square minus A square by 4. That is nothing but 3A square by 4. Or we can say 4 times of AD square is equal to 3 times of A square. A square is nothing but, let me take AB square or BC square or AC square, nothing, anything you can take. So 4 times of altitude square is equal to 3 times of side square. So 3 times the square of any side is equal to dash times the square of altitude. How many times here? 4 times. So 4 is the answer here. That is nothing but 4th option for us. Okay. Now let us take the next question. DEF are the midpoints of sides of BC, CA, AB. D, E, F are the midpoints of sides BC, CA and AB respectively. Then the ratio of areas of DEF and ABC. We know that as these two are midpoints, here we are going to have 4 triangles of equal area, 4 congruent triangles. In fact, they all areas will be same. So we can say area of triangle ABC is equal to 4 into area of triangle DEF. In fact, you can write anything, but he is comparing with DEF and ABC. I can write this. Therefore, area of DEF, triangle DEF by area of triangle ABC. That is 1/4. 1:4 is nothing but first option for us. That is the right answer. Okay. So that is end of this assignment. Thank you. Have a great day.